We have any plastic.
Jerry! Monica! Ready? Yeah? Singular or plural? Did I write it as a singular?
Yeah.
Okay. That's just a singular. There's, maybe it should really be a plural because there's three bases. Okay. So, last time we were talking about this special point O.
Yes.
But we still have to say where the other points are by some diagram. But what we'll do now is we'll make 3 more special points. Are you ready? I want to get a picture here for you. No, don't do that. Wait. Where's my box gone? Ah. The heck? What the fudge? Oh, there it is. Right. Now, as I was saying, we need to make special points. And these special points are called I and J, for example. Now, what's special about these points is that, number 1, the vector I and the vector J, they're both 1 unit long. So they have a length of 1 unit. And also they're perpendicular. So the magnitude of I equals the magnitude of J, which equals 1. And they are at right angles between them. So, because they have this feature, we call them I and J, we call I and J a base. Now, this is a base for vectors in 2 dimensions. And 2 dimensions we write like this. This means 2 dimensions. And you might be wondering, is it possible for 3 dimensions? Of course, we just need an extra vector, which is k. For or cubed, 3 dimensions, we use I, J, and K. Since they are special, we usually write them a little differently. We put a little hat on the top. So this is to remind me that they're a special vector. Yeah? Got that? You write that down, Sean? Yeah.
What do you mean by 3-dimensional?
I'm going to try and get a picture or try and draw it now in a second. Oh, come on, you piece of junk. Oh, for goodness sake. What?
Why we use R and G?
Hold on. I'll explain now.
How do you count?
Oh, what is with this piece of junk? There we go. Yes, I'll explain now. I just need to try and get a nice picture to show you, since it'll be easier in 3 dimensions. Oh, no, 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 no.
Oh.
Oh, come on. Why is it so hard? Just give me a nice picture. Ah, here we go. Wait a second. Oh. Yeah, I guess we'll do. I guess we'll do. No.
What? Why?
National holiday.
Oh.
Now, can you see this picture?
No.
No, you can't.
Yeah. Last week, Monday.
What television? You're gonna on TV.
Oh, yeah, that's right. All right, well, keep an eye out.
And what have I students?
All right. But you have to email me what float.
Yeah, I will. I'll take a picture with me.
Guys, I can't get the picture, so I'll have to do my best to draw it, okay? Yeah, it's going to be...
Terrible.
No, I wouldn't say terrible, Sean. Just ugly, maybe. There we go. Okay, so in 3 dimensions, it looks like this. O, I, J, Lee, why on earth are you late?
I
Sit down.
sleep over.
Sleepover and whose? Yes.
Like this one.
Yeah, that's 2 dimensions, but
Which one is the J and I? Oh, 3D, 2D.
yes.
Oh,
Yes.
3D, 2D. Wow.
Oh, come on, guys. All right, here's that. So this is K.
Yeah.
So that's vector K, that's vector I, and that's vector J. So if I have some vector like this, Sean, for example, or I may draw it a little bit differently. There you go. Okay, or. So you can see that vector or is 2I plus, it's really hard to draw this in 3 dimensions, 1K, and then up
Oh.
1J. So this is 2, maybe this is 1, and this is 1. So what we say is OR equals 3I, no, sorry, what am I saying? Sorry. Well, yeah, that's not a 3, it looks more like a 2, doesn't it? 2 I's plus 1J plus 1K. That's in 3 dimensions. 2 dimension, of course, is easier to draw. If this is I and this is J, then this vector here, that would be 1I plus 1J. Sometimes they ask you to draw these. Continue.
So how do you know the blue line can reflect to
It's hard to draw in 3 dimensions. What I'm doing is giving like an XYZ information to draw it. Continue?
Yeah.
Okay. So, next. John, you were asking why don't I use X, Y, Z? And the reason is because X, Y, Z usually represents the coefficients. The 2, the 1 and the 1. We use the letters X, Y, Z for them. And of course my writing pad has stopped. Are we back? We're not back. Are we back? We're not back. Are we back? Are we back? Are we back? There we go. So we usually say something like this. Or equals xi vectors plus yj vectors plus zk vectors. Or if it's 2 dimensions, we can just say or equals xi vectors plus yj vectors. So here in this picture, this means x units, y units, z units. And then we have the vector in 3 dimensions. This one here means go out x units, go up y units, and now you have it in 2 dimensions. So this is x units and this is y units. This is x units, y units, and z units. So here is an example there. They might ask you to draw it, but I don't think they'll ask you to draw this. I think they'll just ask you to draw this one. But you know how to, it's not that difficult. It's a bit of a pain to write this all the time, so it's quite common to do this, to write xi plus yj plus zk, to shortly write it like this, x, y, z. Or if there's only 2, you can write it like this. That's just to be convenient. Yeah? Yes? One sec. Yeah?
What is the difference between this and this?
This one? And this one?
But there's something you put like this arrow.
It's hard to draw. This is supposed to be 3 dimensions.
No, I mean the x, y, z, xi. You put something that looks like a triangle.
Like a house.
Yeah, house, line.
This?
Yeah.
Oh, this is just to remind me it's a special vector.
What's the difference between?
No difference between that and an arrow.
Why you put something is arrow and something is
No, because this is a vector,
yeah.
and these are special vectors.
Oh.
What is special?
A special vector.
No,
You can use it as a base.
Just put to the F part.
Where? Here?
Part at first. Yeah, there. You put arrow on the eye and.
Oh, that's a mistake. I'm sorry. That should be a hat. You happy now?
And then
Yeah, I know. I'm very tired. Please.
oh my
Okay.
God! That's because I have some meaning.
No, it has no. The meaning is your teacher's very tired and overworked. Okay, continue. Yeah. Now, a small thing that you might find strange. I drew my I and my J like this, and you might think, okay, that means this is I, this is J, and this is K. It seems natural. But a little bit strange. Whoops, that's not it. A little bit strange. Most people, they don't draw it like this. They put the I, J, and K in a different order. So here is the I, J, and this one's the K. It seems really strange, I know, because why do you move them around when you draw it in this little picture? It's almost like this picture is you looking at the ground. It's like you're standing here, looking down. Yeah, but you might think the only thing you should do when you go from this picture to this is add in the K this direction. But actually this is supposed to be the ground, so it means when you draw it in 3 dimensions you have to flip it a little bit.
This is better.
Okay, then it's not strange then. Let me delete strange and replace it with good. Okay, regardless. Continue? Yeah. So, just to check, I don't know which questions did I ask you to do. So in question 1 I asked you to draw, did I? And one, number 2, simplify, yeah, number 2. Yeah. Yeah, let's have a quick look. I just want to see which ones I... Whoa. Yeah. Now, Lee, listen. Why? Oh, listen, please. I'm so tired. Better check that's not Lorraine. Connell. What does he want? No. I told the January students not to come in till 10 o'clock because Lorraine's not in. And now Connell just said she's in. I'll pass on your positive feelings. Yep. Ah, flip. I knocked out the thing again. Okay. Now, before I was distracted by students and text. Come on there. Why bother using this? Well, we have an advantage. If I say OR1 equals, let's say, x1, y1, z1, and let me draw it here. Let's just say, I don't know. Let's say there's OR1. And if I say OR2 is x2, y2, z2, and let's draw it here. If I wanted to know what OR1 plus OR2 is, I don't need the triangle law. I don't need the parallelogram law. Instead, by using a vector basis, I just have to add these x, y's and z's together. So OR1 plus OR2 will be x1 plus x2, y1 plus y2, z1 plus z2. It's kind of like it, yeah. What's wrong, Sean? Yeah. So for example, if I said 2i plus j plus z plus 2k minus I minus j minus k, that would equal I plus k. Now if I draw that, let's see, that's I, that's j, that's k. So I plus k will be a vector like this in this plane, because it has no j. Yeah. Yeah. Okay, so that's pretty straightforward. Now, a couple of small things. Another advantage of using the basis is that it's easier now to calculate magnitude. So for example, if I have a vector here and this is x units and this is y units, then what's the magnitude of this vector? Yeah, the magnitude is square root x squared plus y squared. But what about if you had 3 dimensions? What would be the magnitude? It would be square root x squared plus y squared plus z squared. Yeah. So that's a formula there. Okay, continue. No. Continue.
Yeah.
Okay. Come on, Jerry, you're killing me here.
Why? Oh, it's this one? It's three-dimensional.
Three dimension. This is the formula for three dimension. Well, you can use it in two dimension as well. In two dimension, you just make z equal 0. Yeah. Continue. Yeah. Okay. So now we need to calculate direction. We kind of did this in physics. So let me just draw two for the moment. So this one here, that's I. And this one here, that's J. And here's our vector here. And I'll call this angle theta. I don't know if you can quite make that out. Let me draw that a little better. Now this angle is on the I and the J. That's theta. And for example, this could be xi plus yj. So this distance here, how big is this distance? X, yeah. And how big is this distance? Y, yeah, which looks like about half of the length. So you probably remember this from physics. How can I get the theta here? No, we don't use sine. What do you use in physics? Yeah, tan inverse
X over
y over x. But that's when it's in two dimensions. What about now if I'm in three dimensions? Let me try and draw that. I, J, and K. And I'll draw it like here. So this one here is x units. This one here is y units. And then the height here is z units. And let me draw a shadow on the ground. So it's like this. So we actually have, can you see, two angles. This angle here, which is theta, and that's still this formula. But we have a second angle because not only is there an angle on the ground, there's also an angle like in the sky. Can you see that there's a second angle here, which I'll call phi? Can you picture that? Now, I really want to show you this picture because this is so much nicer than my picture. Let me try again. Okay. Let me see. Come on. Yeah, works. So can you see that we have a theta on the ground, but we also have a phi in the air. So I've given you the formula for theta. Now what about the formula for the phi here? So let's go back. Okay. So if you want to calculate this phi, if you look here at this triangle, could you know the hypotenuse here? Yeah, what would it be? The hypotenuse here. It would be the magnitude, which would be square root x squared plus y squared plus z squared. Now what else do you know on this triangle easily? Could you know this height? Yeah, what is it? Z. So if you have this which is the adjacent and this which is the hypotenuse, what could you use? Sine, cos, or tan? Cos, yeah. So you can get phi is cos inverse z over square root x squared plus y squared plus z squared. So this is another formula, and this is another formula. So basically for this lesson you have three formulas. You have the formula for magnitude, the ground angle, and then what you might call like the sky angle. One on the ground and one in the sky. So you have three formulas here. The other one was up there. 1, 2, and 3. Yeah? So let's practice one. I'll let you try this one for me. Find the magnitude, the theta, and the phi for I plus 2j plus 3k. Alright, so let's do the first part. What's the magnitude here? Square root, yeah, 1 plus 4 plus 9. So that's square root 14. Okay? What's the theta? The theta is tan inverse 2 over 1. What's that, please?
Radian or?
Degree is fine. Okay, and then the phi is tan inverse 3 over root 14. Okay, so if I was to draw this, oh thank you, remember, tired teacher? Okay, cos inverse, I did that on purpose to test you. Cos inverse, what's the angle here? Wow, so different. Okay, draw. So, I, J, K, I, J, K. So the first one is 1, 2, and then 3. So here is the vector, whoa, here is the vector R. But also I know that its length is root 14 units. I can also know that this angle here is 36.7. And then if I draw the shadow on the ground, if I put the shadow here, this angle here is 63.7, like this. Okay.
No.
Yeah, 0.4, yeah. Goodness. So not too difficult, right? It's only got 3 formulas. Now, I should tell you that sometimes people swap the letters theta and phi. So some people use theta on the ground and phi in the air, and some people use phi on the ground and theta in the air. And I can't remember which I used in the book. I think I might have did it backwards in the book. I don't know, because it doesn't come up till question 6. I have a feeling that I have these the other way.
No.
It might be backwards.
Yeah.
Well, not that it's backwards. It's just a letter. I'm just letting you know. 50% of the time, people might write theta here and phi here, and 50% of the time, they might write phi here and theta here. Yeah. Okay. There's nothing really extra to say about that. I'll tell you for the exam. This is too easy for the exam. We're doing this so we can do the next lessons, which will be on the exam. Yeah. Actually, you know what? I can check right now which angle I use. So, for example, if I do tan inverse minus 38 over minus 95. That's 21. So that's the ground angle. So 21. Oh, yes, I just need to swap these. Sorry. I didn't say which is theta, which is 5. So it doesn't matter. Okay, can you try these now? Can you try these now for a few minutes, please? Thank you.